Welcome, everybody, to the GL monthly webinar. This month we'll be discussing the automated IVR and voicemail testing. The speakers are myself, Rob Bishevsky, and also one of our senior techs, Mike Yang, and he'll be giving the bulk of the discussion about how we provide testing for IVR and voicemail. So let me give a brief understanding of GL itself. So very briefly, GL Communications has been around for over 30 years. We have 3 offices, one here in the U.S. on the East Coast, one in Bangalore, India, and one in Shanghai, China. What we do is we provide product for testing, analysis, monitoring of pretty much any type of telecommunications. And we also provide consulting services for mass transit, any type of services, emergency services, things like that. In terms of our products, we get into TDM, into VoIP, into mobile. Again, pretty much anything that you would require, we can do that type of testing. Okay, so let me go over to get started with our webinar itself with the IVR testing. So the IVR and voicemail system, what Mike will be talking about, basically we have products that can connect to pretty much any interface. So we can connect to 2-wire, to SIP, to legacy T1E1, to a mobile interface, to just a headset type interface. So we can connect to any type of interface, and we can control the call, basically bring the call up, tear the call down, and then once the call is up, we can go through the entire IVR or voicemail system. What that means is not only going through the IVR by sending the appropriate DTMF digits, but also and by sending the voice prompts, sending voiceover to test it in that manner, but also listening to what's coming back to us, listening to the prompts coming back to us, and analyzing that, evaluating that, and determining which way to go and confirming that the prompts themselves are proper that are coming back to us. So we do the entire test, the entire solution, all within our system, from start to finish, testing the IVR voicemail. So I'm going to turn it over to Mike now, and he's going to go through the entire process and how we do this and how we set it up. So, Mike?
Okay, thank you, Rob. So I'll be going over the testing solutions that we have for testing IVR and voicemail systems. So as Rob has already alluded to, GL has basically 2 main voice or call testing platforms. They're known as VQuad and MAPS, both of which can be used to simulate IVR users as well as IVR systems to perform IVR tests. Both VQuad and MAPS allows us to connect to different networks, whether it's via T1E1, analog, digital, IP, or wireless interfaces. So that means we can basically connect to any network, any interface, and test the IVR system. Using the VQuad and MAPS application, both of which are scripted and can be automated, we are able to control the entire IVR testing process from a user's perspective. So that includes setting up the call, recognizing different IVR menus and all of its options, and generating responses to either DTMF or voice. And at the end of every call, we generate a report which shows a overall result of either a pass or a fail. And we also show analysis that happens at each IVR prompt or each IVR stage. So this allows us to completely automate the IVR and voicemail traversal process without needing any manual input from users. So this means it saves time and resources, and it's very cost effective. And all of our systems or our test platforms have CLI or API support, so it can also easily integrate into any test automation platforms. And while it's not the focus of this webinar, the test tool can also be used to simulate an IVR system by scripting. So that would involve playing voice prompts at each stage, recognizing a user response, whether that's DTMF or voice, and then present the next prompt based on the response. So what we have is a very flexible solution that should suit all of your IVR testing needs. So with our earlier implementation of IVR testing, we mostly relied on two methods. So we can either blindly respond to prompts by simply waiting for some duration. So for example, you connect a call, wait for 10 seconds, assume that a prompt is playing at this point, and then blindly just send a digit. Or the other method, the second method, would be to use voice quality measurements to confirm prompts. So that would involve setting up the call, recording the voice prompts, and then performing some sort of waveform analysis of the recorded prompt, and then compare that to what the referenced voice prompt should be, and then provide a voice quality score. And if that score was good or it's above a certain threshold, we can assume that the voice prompt is correct, and then we can proceed and respond to the prompt. But the problem with that is, you have to have, first we have to have reference voice files for every prompt that you need to test. But this method is also a bit error prone, and it's difficult to know when you should start recording, how long to record, and what exactly constitutes a good score, because if there's bad voice quality on the line, if the network is not good, then that can affect the decision making. So with the new approach that we are introducing today, we'll be relying on speech-to-text transcription to determine how to traverse to IVR systems. And I'll dive a little deeper into our speech-to-text application in a few minutes. So in addition to IVR system testing, we are also able to monitor IVR systems for voice and data quality and perform audio quality measurements such as POCA and PESC on narrowband and wideband high-definition voice. And additional measurements such as one-way or round-trip delay are also available. We can perform P56 analysis, including speech activity, active speech level, noise level, total RMS power, and so on. And then for voice over IP calls, we can calculate RTP voice quality metrics such as R factor, listening on conversational quality MOS scores, and provide additional packet information such as packet loss, packet discarded, out-of-sequence packets, or duplicate packets. So at the heart of our new IVR testing solution, and the main product that we're introducing today, is our speech-to-text translation application called the Speech Transcription Server, or STS. And at its core, what the STS does is it translates or transcribes spoken language into text by performing speech-to-text transcriptions on captured audio files. It is a cloud-based transcriber, so internet access would be required. And of course, we do recommend a strong internet connection, since we know that IVR testing is very time-critical, where in many cases you only have a small window to respond to the prompt that you want to test. And internet speed can affect the time it takes to perform the transcription. and often also affecting the time needed to respond. So a strong internet connection is required here. The STS can monitor directories for audio files and then automatically provide a transcription for each file. So this means that while the STS is running and let's say monitoring a particular directory, anytime a new voice file is added to the folder, the transcription just happens automatically. In addition to transcribing text, we also provide analysis of the transcribed text when compared to the expected text. And that includes a quality score of how similar the two texts are. Since we know speech to text is not an exact science, so we need this quality score in helping us navigate through IVR prompts. So the STS supports multiple languages, such as English, German, Italian, and Spanish, just to name a few. And then to the left here is a list of all the languages that are currently supported. And we do plan on adding more languages in the future. But something to note here is that for IVR testing, we currently only support sort of Latin alphabet-based languages. Because that's so for the speech or for the text analysis portion, those are the languages that we currently support. So from this list, so languages like Arabic, Chinese, Japanese, Russian, languages that don't use a Latin-based alphabet, those are not currently supported, but we will look to support them in the future. And then lastly, a text-to-speech synthesizer is also included with this application. And that is to create voice files for IVR prompts that require a voice response. And the text-to-speech also supports all of the languages that's listed on the left here. So the speech transcription server can operate in two modes. The manual mode, which is in here, lets the user transcribe a single file manually. So the user just needs to give the path of the file, specify the language of the voice file, specify what the encoding is if it's a PCM file. If it's a WAV file, then you don't really need to specify that. And then once you click transcribe, we provide a transcription along with a certainty or confidence score of the transcription. This certainty score is given by the speech recognition engine, and it's a score between 0 and 1, and it shows how confident the speech recognition engine is in the transcription. And this score is used alongside the text comparison that we perform on the transcribed and expected text. The second mode here that you see here is the automated mode. And this is how the application will be used for IVR testing. In this mode, we use directory watchers to monitor single or multiple directories and look for newly created audio files. Each directory you can configure with information such as the language and coding type. And then the transcription results are populated in the GUI under the results tab that you see here. The results are displayed in real time as the transcription happens. They're populated in this tab and also stored in a database. This directory, the directories can be color-coded so that if you have, let's say you're running multiple directory watchers, you can easily spot which transcription belongs to which folder. So that's just a ease of use thing that we've added. It is able to monitor up to 60 directories simultaneously, and then each file transcription happens through an independent process. So what that means is it allows for high concurrency when running the STS, so you can have multiple folders running, transcribe multiple files all simultaneously. Okay, so now let's put the tools together and show you a typical use case. So here we're simulating a voicemail user who is placing a call into the IVR system. And as soon as the call is connected, we can start the recorder in our test tool. So at this point, we're expecting the voicemail system to say something like, you have 2 new messages, press 1 to hear the new messages. So the recording happens until it has detected silence. And when silence detected, we stop the recording, and the file gets sent to the transcription server, or the transcription server will actually automatically pick up this recorded file since we're running it in the automated mode. The audio file then gets sent to the cloud for analysis, and results get sent back to the STS, and it is picked up by either VQuad or maps, and then analysis, text analysis is performed on the text. And if the results match our expectation, then we can respond with a DTMF digit. In this case, we'll respond with a DTMF1 to retrieve the new messages. So we can then continue this process until the voicemail is retrieved and verified, and thus verifying the voicemail test case.
Mike, let me chime in for a second if I can, okay?
Sure.
So this is pretty cool if you think about it. Just to give you a very brief look at this. So by using either our maps or our VQuad, we can, just again, I just want to go over what Mike just went through. We can call up the IVR system or the voicemail system. Okay, so using our products, we're placing the call. We're getting into the system. So now we're in the system. And we're confirming that by the responses from the system, whether it's a ring back, it's whatever type of call progress tone that's coming back, we're detecting all that. So we're making the call, we're confirming the call is up. So now we're in the call. Now we're listening to the system, to the voicemail or the IVR. We're listening to the prompts coming back. As the prompt comes back to us, the maps or the VQuad is doing all the heavy work. So it is taking that file or recording that file, the prompt coming back, sending it out to the speech transcription server, which goes out to the cloud-based transcriber, comes all the way back as text. So the maps or VQuad is doing all that heavy lifting for you. It's doing everything. As it comes back, we can then analyze what came back. So Mike said, okay, we called this, and it says press 1 to retrieve your messages, whatever, right? So now we're gonna analyze that. So we're gonna record that prompt. We're gonna confirm, yes, that's what the prompt said. So as you go through the IVR, and you're expecting a specific prompt, if that prompt doesn't come, we'll know that. We'll know something happened to your IVR system. We'll know that the expected prompt, which was press 1 to continue, wasn't heard, and in fact, a different prompt came up and said, you're now in a different location in the IVR system. So we'll know that. And then we can take action within our maps or VQuad to generate an error or generate some sort of an event that lets you know, no, your IVR system did not work. It didn't do what you expected it to do. Okay? So now we've got that prompt. We've analyzed that prompt. We've generated some sort of an event with that prompt. Now we're going to go through the IVR to the next step, and we're going to send a DTMF, or if it said press 1 or say continue, we can also send a voice prompt. So we can send voice back up to the IVR or send a DTMF to the IVR, so you can traverse through the IVR in different manners. And you can build these scripts up so that we can go through the IVR, going this way, that way, and the other way to get to a certain point, and then set up another script to get to a different point in the IVR, and basically test the entire IVR. So this is great for recurring tests. So you can build these scripts up. Doesn't take long to build the scripts. Doesn't take long to set this up. And now you have your set of scripts. Maybe it's 20 scripts or 30 scripts, whatever. Now you say, okay, let's just run the whole thing. Let's do a full test on the IVR or the voicemail. And go through that whole process and come back and say, yeah, I got 7 errors based on this testing. So it's really great because it's an exact thing. It goes through the process in a specific manner, and it analyzes what it receives back. Very, very important. So sorry, Mike, I just wanted to chime in with that.
No problem.
Okay, go ahead.
All right, so let's go back and talk a little bit about the different test platforms that we have, and just highlighting some of the similarities and differences between what the VQuad and MAPS offer and how they might fit into your testing needs. So the VQuad allows for VoIP, TDM, analog, and wireless testing. And that's the 4 different areas, and actually that's what the quad part of VQuad stands for. So for wireless testing, we can do Bluetooth, Wi-Fi, 3G, 4G, push-to-talk using our hardware solutions such as the Dual UTA or the VQuad Probe. So for example, this allows the VQuad to directly connect to, let's say, a mobile phone through the Bluetooth and perform automated testing directly using that mobile phone. The VQuad also supports, has wideband support for Bluetooth, FXO2 wire or SIP. The FXO portion is worth mentioning here because it's currently our only solution that does wideband to wire testing. The VQuad can also easily integrate with your existing endpoint interfaces, so that allows you to basically test with your existing equipment and then test virtually any network. The diagram that we show here is a VQuad HD, which is a rack-mountable 24-port FXO simulator. So it's able to simulate 24 FXO lines for either narrowband or wideband analog voice testing. The VQuad is also available in a semi-portable unit called the VQuad Probe that connects to that, I guess, in itself is a PC, and it's a sort of a portable solution that you can take with you to perform different tests at different places. And in addition to performing IVR tests with VQuad scripting, the VQuad provides additional quality measurement or voice quality measurements, echo and delay tests, and voice band analysis capabilities. So MAPS, on the other hand, MAPS stands for Message Automation and Protocol Simulation. It's our homegrown protocol simulation platform. And as you can see in this graphic, it's capable of simulating many telecommunications protocols ranging from analog 2-wire all the way to voice over LTE. The MAPS architecture has 3 layers: scripts, messages, and profiles. And when we put those 3 together, it creates a very powerful and flexible solution for doing all kinds of protocol testing. So MAPS supports media traffic over TDM and RTP. So you can generate or receive traffic such as voice files, single or dual frequency tones, DTMF or MF digits, and it supports all the industry standard codecs. So similar to the VQuad, this also allows you to make IVR test calls over pretty much any network. So I guess the difference here is that we're simulating endpoints instead of integrating with existing endpoints. So by simulating endpoints, this sort of allows us to scale easily for bulk call testing and test multiple IVR paths in parallel. Since in most cases there's no actual hardware involved, and this is mostly done in software. This diagram here shows a 192-port FXO test solution with all independent line controls, and it sort of fits in a 5U rack system, and all 192 ports can be used simultaneously for IVR testing. So this is a higher scale than what the VQuad can offer. But regardless, both test platforms can be used for IVR testing. It's just a matter of needs for how you need to integrate with your network. Both VQuad and MAPS provide a report at the end of a test, as I had mentioned before. And this report contains a overall pass-fail information, transcribed text for each prompt, and then for each prompt you can provide a similarity score or some quality measurement that compares the transcribed text with the expected text. And then for VoIP calls, we'll include various RTP voice metrics and packet information that shows the natural quality. And all of the results can be passed to a database which can be accessed via a central sort of aggregate system such as our web viewer or NetServer Web. And from those applications, you have the ability to view the results for every call in a tabular form sort of through a web browser. You also have the ability to create custom reports where you can choose what information you want to include in the report. And the reports can be scheduled with user-specified filters. So, for example, you can schedule a report for every time that you want to run a suite of IVR tests. And at the end of the test, a report will be generated, and it can be shared automatically via email. Okay, so now let's take a look at a sort of a concrete example of a IVR traversal. The diagram that we're showing here is the IVR structure for our GL's phone system. So when you dial our phone number, our main phone number, this is the IVR system that you'll see. So we can divide the system, the IVR prompts, into different stages. So for example, at the first stage, it'll play the welcome greeting, and then it'll play the different options to reach the subsequent IVR stages. So for example, you can press 1 for sales, press 2 for technical support, right? Press 3 for a directory by last name, and that's all labeled here by the digit assigned to each option. So for each of these options, the IVR system is expecting a DTMF response. So some of them, obviously, if you press 1, it'll connect you directly to sales, right? If you press 2, it'll connect you directly to technical support. So I'm not going to focus on that. Instead, we'll examine the third option, which is the directory by last name. So the goal here is to basically traverse to this directory by last name menu and then ultimately reach or find a matching person at GL. So the path we'll take is highlighted in green in this slide. So we know ahead of time what the prompts are going to be expected in this tree, and we can then divide this into 3 stages. So the first stage, we'll verify that the welcome greeting and all the different menu options are played properly. If this is confirmed, we'll respond with a DTMF digit 3, which gets us to the second stage, which is the directory by last name. Once we reach the second stage, we'll want to verify that the directory prompt is properly played. So, for example, here we're going to expect to hear the phrase, please enter the first 3 letters of your party's last name. If this prompt is confirmed, we'll respond with the 3 DTMF digits that matches someone here at GL. And that takes us to the third stage. And then at the third stage, the IVR the directory system will play back all the matching results from the 3 digit that we entered. And so the IVR test system will just monitor for those responses. Once it finds the specific person that we have in mind, we can respond with a 1, and that'll connect us to a matching person. And so at any point during this test, if, let's say, a prompt doesn't match what we're expecting, we can just say that, this test failed. We didn't find the prompt that we were expecting, and the fail log will show you where it failed, what the transcribed text was compared to what we were expecting, and so on. Okay, so how do you configure the test tool to traverse through these prompts? So as the previous slide suggested, we'll divide the prompt into 3 stages. So the user can program each stage with the following information. So what's the language of this prompt? What's the expected transcript? An optional trigger phrase, which decides when the response should be sent. So if that trigger phrase is detected, we send the response automatically. If this optional trigger is not given, then we'll simply just look for the last few words of the expected transcript. Then the user also programs what the expected response should be, whether it's a DTMF or a voice. If it's voice, what should the response say? So once the voice is entered, we'll do a text-to-speech synthesis and then generate a voice file which can be used to send the response. So all of this information is configurable via profiles, or you can store it in a CSV file or a database, and it's basically up to you to decide how you want to store this information. We're pretty flexible. The main information that we need are what's shown here, so you can get that information to us pretty much in any way that you prefer. So here's what a traversal looks like running in our map SIP application. So we can place a SIP call into the GL phone system, and as soon as the call is established, MapSIP just automatically starts and goes into the IVR traversal mode. And then transcription at each stage are made available and displayed in this ladder diagram as soon as the speech transcription server transcribes them. And based on the information provided by the user, we'll send the response when it's appropriate. So in this case, we're dividing the first stage into different sort of sentences, and we're transcribing them as they come to us. Once we reach the end of this prompt, which is to speak to operator .0, we'll transmit the 3 to reach the directory by last name. And in this example, we can gather all of the prompts from stage 1, and then we can compare that to what's expected, and then provide a similarity score. In this case, the score is a 0.91, which is really good. That matches pretty much what we're expecting through this prompt. So we try to keep the configuration as simple as possible, and all you need to give us is pretty much just the expected transcript and how we should respond. And if you are interested, we do have a short video on this application on our website. You can find it by either going to the speech transcription server page or the IVR testing page, and that shows sort of a live traversal of the GL phone system using the MAPS APS application, which is the analog phone simulator. Okay, and so before I wrap up the presentation, just want to briefly go over our IVR call monitoring capabilities. So as you may know, GL has a suite of call capture and analysis solutions that can be used to capture or monitor live traffic over TDM and packet networks. For each call that we capture, we can provide a sort of comprehensive report that shows the complete signaling for each call, detailed voice band event information such as dual tone, fax tones, modem signals, and detailed analysis of the voice band. So information such as noise level, speech activity factor, echo measurement, etc. The voice can be captured in both directions, and then we can also provide a transcription for the voice that's captured. All the alarms or errors that occur during the call can be captured. So basically, this is just all the information provided here can be helpful when you want to use this either alongside our test tool or as a standalone test tool to sort of confirm that your IVR system is working as expected. Okay, so that concludes our presentation, and I think we'll open up for any questions that you guys might have.
Yeah, thank you, Mike. I think we have some questions.
So first of all, we can go through and test the voicemail system.
Yes.
Second of all, we can confirm that what we're getting back is proper. Okay, using the speech to text, or we can also use voice quality to check the quality of the voice coming back. If it's also generating an SMS, we can check that as well using the our VQuad and looking at the SMS. So we have ways to look at the SMS there. Does that make sense, Edmund?
Okay, yes, okay. Yes, so and
so it really is a full, complete solution. I mean, depending on what you're setting up, but it is a full solution the way we do this.
I have another question. What about your experience? My experience with the voice recognition is bad. So I tried to use the voice recognition by my key customer to contact some individuals, but it's never worked correctly. What about the text to speech and speech to text? It's working better than voice recognition?
Well, the speech to text works pretty good because what we're doing is we're capturing the voice, we're transcribing it to text, and then we're only looking at keywords that were transcribed. All we're doing really is confirming that that was the prompt. So we don't really care about if there was a poor voice quality, if there were even some drop packets. Doesn't matter to us as long as we can see a high percentage of the keywords that were in that prompt. We can confirm that, yes, that was the proper prompt. We are in the proper place within the IVR. That's what we're trying to do.
Now, my question was regarding your experience. If this text-to-speech and speech-to-text is better than speech recognition?
Well, this is, this is in a way speech recognition because we're taking the speech and we're converting it over to text, and then we're analyzing that part and confirming it against the what we're expecting. So, I mean, we have two methods to do this. We can either do it using a voice quality, like using Pesky algorithm, and confirming it against a voice prompt, or we can use it by transcribing the speech into text and then analyzing that against a prompt, which, again, as I said, will only have keywords in the reference prompt, and all we're trying to do is confirm, yes, that was the proper prompt. And that's all we want to do.
Is this process taking a lot of time?
No, seconds. Very quick. I mean, as Mike said early on in the conversation, you have to have a good internet connection because it is going out to a cloud-based transcriber. Okay?
Thank you. Bye.
Sanjeev, were there any other questions?
We have another question. Can our system work with any of the IVR systems in the market?
It doesn't matter. We can work with any IVR system because we're basically, as Mike went through the presentation, we're basically calling into an IVR. So we're calling into that number. And then as long as, and what we're doing is we're testing the process of the IVR. We're testing the, going through that IVR. So as long as we have the prompts predefined and where we're supposed to go through that IVR and how we're supposed to go through it, that's how we script it. And again, so we can go through any IVR, any voicemail system, confirm that things are working properly, and traverse through these IVRs using either DTMF or sending voice to get through. So you may want to test it two different ways. You may want to let's test it using DTMF. Let's see if the DTMF works. Let's see if we get to the right point. Okay, now let's test it using voice, spoken voice. So let's send spoken voice through the IVR and see if we get to the same point. So any IVR, any voicemail system, pretty much any interface we can support.
Yeah, thank you, Rob. One last question we have is what type of analytical results are generated?
That depends on what you're setting up in the maps or the VQuad scripting. So we can get results such as, was the prompt detected, was the proper prompt detected, were you in the proper location of the IVR, okay, or did it, did you get to the wrong point by sending the predefined digits or voice. So we can provide error conditions based on where we are or what we're retrieving back. We can also perform, as I mentioned to Edmund, we can perform voice quality during the IVR. So we can do a voice quality test once we get into the IVR, once we get to a certain point where certain, for instance, we're retrieving a voicemail, we can then do voice quality on that voicemail to see what the network is doing, how the network is. And then we can do other metrics while we're doing the test, like speech and noise level and power and things like that. And this is basically just saying, well, how is the network? How is the IVR, the network which we're going through to get to the IVR, how is that? Okay, so we can analyze that.
If anybody has any other questions, you can just send us a mail at info@gl.com and we'll answer it. Thank you, Mike. Thank you, Rob.
Thanks, everybody. Appreciate it.
Thank you.